So last time we left off, and we successfully figured out essentially the forces that would essentially reach the maximum before I started moving the car. And we previously said that when I was in Pittsburgh, or Louisville, Ohio, technically, I could exert a 3,000 Newton force. So I should have been able to move the car, but for some reason, it didn't work. So I have a suspicion. I think, again, I bought my first car in Pittsburgh. It is a Jeep, 2017 Jeep Cherokee Trailhawk. And I think that when I put my brakes on, I think that both brakes were locked. So let's see if that will explain essentially what's happening here. So we're going to look at, again, what's our first step? Let's idealize our system. So same idealization here. So same system effectively we're working with. So first step, done. Coordinate system. Same coordinate system here, fantastic. What about free body diagram? Free the body. I'm still going to have friction here. And remember, tangent to the contact surface, I'm not going to draw it because it's a free body diagram, and oppose the impending direction of motion, which is here. So I'm going to have to add in to my previous expression another frictional force. So let's go ahead and do it. So I'm going to take this whole expression. Actually, I'm going to keep this so that we can compare. Because one of the important things is when you're solving some of these problems, what do you expect to change in the system? If I have both brakes locked, what's going to change here? Well, I should expect to see that this should be even larger, right? It should be harder to pull with two brakes. So let's go ahead and see if we can do that. So I'm going to quit and clear the kernel here. It's just going to clear all my variables. So my knowns are the same here. My summation of forces in the x, now it's F1 minus F cosine theta degree. But now I'm going to do what? I'm going to add another F2 term. And how can I define F2? Well, F2, it still has to have, again, it's the coefficient of friction times that normal. So it's going to be US times FB. So let's define it here. Let's define it here. And I'm going to go. Y, nothing changes in the Y. And I will do it correctly this time, as you can see. What about my moments? The moment, nothing changes here. So at least with all those other terms, those are the same. Because if I want to do my moment about C, so this is F sub 2. So if I have a moment, and this is my line of action right here, where or what is the perpendicular distance? The perpendicular distance is 0. So we're not going to have any contribution from this F2. So my expression remains exactly the same if I'm looking at the moment about that C point. So with that, I've got how many equations? 1, 2, 3. How many unknowns? FB, FC, F. Let's solve. And voila. So we see here, okay, I was able to exert 3,000, but I can't not move it because it's 4,000. So everything makes sense in the world. I'm stuck now in Louisville, Ohio, freezing. And so now we have to kind of work through that. Fantastic. So this is a great start. But now I have another story to tell you. But you're going to have to wait until the next video in order to solve the next problem. But it's a good one. It's a doozy. It's a ladder. I have a lot of work to do once I get back. So I hope that you enjoy it. So I'll see you all in the next video. Thanks.